Hello students, let us solve some important question and solution on double integration. Already I have uploaded some important solutions on line integration. You may check the link in the description box and in the I button above. So now solve some important questions on double integration. The first question is, find the area of the region bounded by the curve y equal to x square and x equal to y square. So let us start the solution. So first thing is, for finding line integration or double integration, we have to understand the curves and the region. So in this question, the curves are bounded by y equal to x square. Actually the curves are y equal to x square and x equal to y square, and the region is bounded by these two curves. So the first curve x square equal to y is the upward parabola passing through this origin, and the second curve is x equal to y square. This is this side parabola. Already in the previous lecture video we have solved the point of intersection of these two curves y equal to x square and x equal to y square are the points O00 and A11. You may check that calculation. So the region is bounded by these two curves, that is this shaded region is the given region. So now we have to calculate the area of this region. So you know that area equal to double integration over the region R dx dy. Now the only thing is to find the limits of these two integration. So the easiest way is to take a strip. I am taking here a vertical strip by which we will solve this double integration. So you also may take the horizontal strip. Now in this case we will be getting the limits for y because we have taken a vertical strip. And how to get the limits? So the lower limit of y will be the lower curve which is touched by this strip, and the lower curve in this case is x square equal to y, and the upper curve of the strip is x equal to y square. So by this strip we will be getting the lower limit of y is y equal to x square because this curve is touched by the strip. So the lower limit is y equal to x square and upper limit is also the upper curve. So y square equal to x, that is y equal to square root of x, since this is in the first quadrant. Now since we have taken this strip which is also movable, we have to assume that this is movable from the first end to the last end. Okay, so from O to A, and in this case the limits of x is 0 to 1 because for O x equal to 0 and for A x equal to 1. Now we have to just calculate this integration. So for dy we will be obtaining y, and limits are x square to square root of x and x equal to 0 to 1. Again this is square root of x minus x square dx, and if we calculate this then 2 by 3 x to the power 3 by 2 minus x cube by 3, and the also limits for x is 0 to 1. So 2 by 3 minus 1 by 3, that is 1 by 3 is the final answer. So the area of the region bounded by the curves y equal to x square and x equal to y square is equal to 1 by 3 square unit because area. Now let us solve another question. So the question is, we have to calculate x square plus y square dx dy where R is the region bounded by y equal to x square, x equal to 2 and y equal to 1. These two are line and y equal to x square is a parabola. So again we have to draw the region. So let this is x axis and y axis, and since x square equal to y is the parabola, this is upward parabola, let us name x square equal to y, and let us draw y equal to 1. Y equal to 1 is this line parallel to x axis, and x equal to 2 is the line parallel to y axis. So the region R is actually this shaded region because bounded by these three curves is this region. Now we have to calculate double integration of x square plus y square dx dy over r. And the only thing is left to find the limits. So again take a movable vertical strip, and then the lower limit of the y will be the lower curve and upper limit will be the upper curve. So lower curve in this case of the strip is y equal to 1 and the upper curve is y equal to x square. So by this we are getting the limits for y, and then we have to find the limits for x. So in this case y equal to 1 is the lower curve which is touched by the strip, and y equal to x square is the upper curve which is touched by the strip. And then for x, this is one end and another end is the line x equal to 2. So for this case we have to find the value of x, since in this curve y equal to 1 and x square equal to y intersect at this end. So x square equal to 1, and if we put y equal to 1 then x equal to 1, because this is in the first quadrant. That is the limits for x is 1 to this line is x equal to 2, because we always assume that the strip is movable from one end to another end, and hence the limits for x is 1 to 2. Now only thing is to calculate integration 1 to 2 x square y plus y cube by 3 y equal to 1 to x square and dx. Now just put the values, which is x square, and then it will be x to the power 4 plus x to the power 6 by 3 dx. It will be minus y equal to 1 if we put, then x square minus 1 by 3 dx, and then the calculation will be x to the power 5 by 5 plus x to the power 7 by 21 minus x cube by 3 minus x by 3, and we have to put the limits x equal to 1 to 2. This will be 32 by 5 plus 2 to the power 7 is 128 by 21 minus 8 by 3 minus 2 by 3. Now for the limit x equal to 1, it will be minus 1 by 5 minus 1 by 21 plus 1 by 3 plus 1 by 3. So plus 1 by 3 plus 1 by 3 is cancelled out with minus 2 by 3, and this will be 31 by 5 plus 128 minus 1 is 127 by 21. This is simple calculation, you all can do this, and minus 8 by 3. So it will be, the LCM is 105, and if we calculate, this is 651 plus 5 and 3, so it will be 635 minus 280. So it will be, if we calculate, this is 1286 minus 280 by 105, and then if you subtract, this will be 1006 by 105. This is the final answer. Next question, evaluate double integration of the function square root of 4x square minus y square dx dy, where R is the region, again triangular region bounded by y equal to 0 line, x equal to 1 line and y equal to x line. Since this is a triangular region, first draw the region. This is x axis, y axis, and y equal to 0 means x axis. So this is y equal to 0 line, x equal to 1 is a line parallel to y axis. This is x equal to 1, and then y equal to x is a line passing through origin. This is what, and this shaded region is our R. So again we have to calculate double integration square root of 4x square minus y square dx dy. So only thing is left to find the limits of this region. So the simpler way is take a vertical strip which is movable from one end to another end. So we know that the lower curve will be lower limit of y. So the lower curve which is touched by the strip is lower limit, and the upper curve is y equal to x here. So 4x square minus y square dy dx. And then the limits for x is at the left end the value of x is 0, and at the right end the value of x is equal to 1. So limits for x are 0 to 1. Now only thing is to calculate. This you can do. X equal to 0 to 1, and you can see that this is a formula. Okay, so which formula? Square root of a square minus x square. So a is here 2x whole square minus y square, and dy, also one integration sign will be there, y equal to 0 to x dy dx. So what is the formula? Integration a square minus x square, or a square minus take y square, because we have y square here, dy equal to, the formula is y by 2 square root of a square minus y square plus a square by 2 sine inverse y by a plus c. C is a arbitrary constant. So now just write again the calculation part. So the integration 0 to 1 and y equal to 0 to x root square root of 2x square minus y square using the above formula. So using the above formula we can write this will be, since a is 2x here, so y by 2 and 2x square minus y square plus a square is 4x square by 2 and then sine inverse y by a over dx. So solving this, integration x equal to 0 to 1 y by 2 and 2x square is equal to actually 4x square minus y square, plus you can cancel out 2 by 4. So 2x square not cancel out, you can divide 4 by 2, 2x square sine inverse y by 2x. Oh, one more thing is left there, that is we have to use the limits y equal to 0 to x. So if we put y equal to 0 to x, then it will be 0 to 1 x by 2. This will be 3x square square root of plus 2x square sine inverse x by 2x is 1 by 2, and if we put y equal to 0, this part will be 0, also sine inverse 0 is 0. Now integration 0 to 1 root 3 by 2 x and x square dx plus 2 sine inverse 1 by 2. Actually we can put the value of sine inverse 1 by 2 and then x square 0 to 1 dx. Okay, we will be putting in the next line. So root 3 by 2 x cube by 3 0 to 1 plus 2 sine inverse 1 by 2 is actually pi by 6, because for pi by 6 sine pi by 6 is half, and again x cube by 3 0 to 1. So the final answer is root 3 by 2 1 by 3 plus pi by 3 into again 1 by 3. So finally we are getting root 3 by 6 plus pi by 9. This is our final answer. Okay, so next solve. Evaluate integration 0 to a 0 to square root of a square minus x square plus y square dx dy by changing to polar coordinates. So let's start the solution. You can see that we have the limits including y. So this is obviously limit for x, because also dx is written in the first. So this is a limit for x. That is, if x equal to square root of a square minus y square, then x square equal to a square minus y square, and then x square plus y square equal to a square. So this is a equation of circle with center at origin and radius equal to a. So we can draw the region, and this part is a, which is radius. So we have to solve this changing to the polar coordinate. Now we know that the parametric equation for circle is x equal to r cos theta, y equal to r sin theta, where theta belongs to 0 to 2 pi. And in this case dx dy will be equal to r dr d theta. So now solve integration 0 to a, 0 to square root of a square minus y square, x square plus y square dx dy. Then if we substitute the values for x and y, x equal to r cos theta, y equal to r sin theta, then x square plus y square will be r square. So just substitute this, and dx dy equal to r dr d theta. Now only thing is to find the limits for r and theta. So for r, actually we have to understand the region here. In the question it is given 0 to square root of a square minus y square. That is, we are given with the first quadrant of this circle, the only one part. So and y is equals to 0 to a. So only first quadrant is given, the shaded region. And if you understand what is r theta, so if we take a point on the circle p r theta, then r is the radius vector and theta is the vectorial angle. So radius vector r is coming from center to the point A. Then theta is coming from 0 to 2 pi. But only in this case, since first quadrant is given, so theta will be 0 to pi by 2. Okay, again understand the region. So we are given with this first quadrant, because x value of x is 0 to square root of a square minus y square. So only first quadrant is given. And if P is a point on the circle over the perimeter, then r is this, theta is this vectorial angle and r is the radius vector. Okay, so r going from 0 to a, because radius is a, so we can write the value, the limits for r is 0 to a, and limits for theta will be 0 to pi by 2, because only first quadrant. Now the thing is just calculate. So this is r to the power 4 by 4, 0 to a d theta. So 0 to pi by 2, a power 4 by 4 d theta. If you solve this, a power 4 by 4 into pi by 2. So the final answer is a power 4 pi by 8.